10.2, we are going to look at moving in between radical form and introduce you to a new type of equivalent form, the exponential form. So notice here, it starts by saying rational exponents. Remember how I'm always saying if you think about a ratio as being another word for a fraction. So what I want you to think about there is ratio, always looking at that root word ratio and thinking fraction. So we're looking at fractional exponents. You can think of it that way. So a radical will have a rational exponent. So it's a bit like learning different forms of, I don't know, even just that you have a decimal form of a number and a fraction form of a number, that those two mean the same thing, even though 0.5 looks very different than 1, over 2. So it's a bit like that. So it's a new form that will look really different, but yet is going to mean the same thing. So the most basic one that we use the most often, that we want to first just observe here, is our a to the 1/2 power. So when we're working on a plain square root, that is the same thing as a to the 1/2 power. And in particular, let's look at how it is the denominator that comes from the index of the radical. Now, there's no exponent on the a, and there's no exponent outside of the radical, so there's like an implied first power here, and either inside or outside the radical. We'll talk about that in just a minute. But that is where the power of the numerator is going to come from, or that's where the numerator of the power comes from. So that 1 comes from the fact that that's just being raised to the first power. All right, now if we observe that then in general, if we have some other index, so a square root is a 1/2 power. All right, now what we want to notice, so first let's just kind of start to make this observation that anytime I have a radical, I have some kind of rational exponent as an equivalent form. So this time the index in this case is some maybe other number other than just 2. And so if that index is some number n, that is now the denominator in my exponent. Again, in this case, we notice on this one, we have an implied first power out here. It's being raised to the first. And so because that is still to the first, that's going to mean that the numerator of my exponent is also to the first power here. So this is to the first power. All right, so we're kind of slowly generalizing, right? We started with a specific and common example, and now we're generalizing. All right, the last form, again, is it's a radical, so that means there will be some kind of a rational exponent, and we have a commonality with the last example in that the index in this case is an index, an nth root, so that is the denominator in my exponent. But this time there is an outer power that is an m, and that m actually can either be inside or outside of the radical, but that power is where we're going to get a numerator power if there is anything there. If not, it's an implied 1. So that is where we would have a to the m over m. Now, as we get into working with exponents, we can still apply the same exponent rules when we work with these fractional exponents, these rational exponents. So let's just start to take a look at some examples. And in the first examples, all we're going to do is move in between exponential form and radical form. So the first couple, I'm going to give us something in a radical form, and then we are going to convert it into exponential form. So suppose I have the 8th root of 5x, and then that whole thing is to the 7th power. All right, so as soon as we see a radical, we're going to think, okay, that means that there is some sort of equivalent exponential form that I can write. Now, what is the a? What is the base of that exponent? So the base of the exponent is whatever is underneath of that radical. So as you go back and, kind of take a look at all the way I wrote it out in general up above, it was just a, so that was pretty boring. But it's whatever is under the radical, that is what is going to be raised to our fractional exponent. So in this case, it is going to be the quantity of that 5x. So if it's more than just an a, if there's more to it than just a variable or a number, you want to put parentheses around whatever that base is. I didn't have to write it up above because it was just a. But if there's more than just a single number or a single variable, you need parentheses around that. Okay, so now let's visualize what we have here. So the radical is what indicates the rational exponent. The index of the radical is 8. So that is going to be the denominator in my rational exponent. And then here I do have an outer power on this. That whole radical outside of that is being raised to the 7th power. And so that becomes my numerator there. So we have 5x quantity to the 7/8. And that would be our answer. Okay, the only other thing, if we wanted to write it this way, I suppose we could say a product can be raised to each factor could be raised to that outer power. So I suppose we could write it as 5 to the 7/8 times x to the 7/8. So that would actually be mathematically equivalent. But what it is not, so it would not be okay to just say 5x to the 7/8, because that implies that only x was underneath the radical. And that's not the case. So whatever is under the radical, that has to be under the rational exponent. All right, number 2, let's look at another example here. Let's just say I have the square root of 3y to the 5th. Okay, so in this situation, this one's a little bit different in terms of that 5. That 5, that exponent, is only applying to the y. It's not applying to the 3. So this time you want to think about, well, kind of like last time, what's under the radical? Well, this time what is under the radical is this entire 3y to the 5th. So that's what's under the radical. So my 3y to the 5th is under the radical. So that's going to be under what's ever going to be raised to my fractional exponent up there. Okay, so in this one, there is an implied, when there is no index written here, we know it is an implied index of 2. So the denominator of my exponent is a 2. So that comes from that implied index of 2. Now here there is no outer power, so there's an implied 1 here. So this really goes back to the most common radical, which is the plain old square root. So a square root, the square root is as we're seeing here, a 1/2 power. It's just that what is under that 1/2 power is whatever is under that radical, which in this case was 3y to the 5th. Now, the only other way you could write that would be to say, because again, a product to a power, that power could apply to both factors on the inside. We could say 3 to the 1/2 times y to the 5/2, applying that 1/2 power to both factors. And then powers of powers you multiply, so 5 times 1/2 would be 5/2. What it is not, and what we'd have to be careful about here, this is not 3y to the 5/2 power. So that kind of makes it seem like only the y is being raised to the 5/2. Like only the y is under the radical, that the 3 wasn't. And so that's an issue there. And another issue that it's not, I have a couple of knots on this one that are common mistakes. It's also not 3y quantity to the 5/2 power. So that implies that the 3 was being raised to the 5th, which it was not. Okay? So, yeah, it's not the easiest thing in the world, is it? As we kind of get in, it's like there's some subtle details. But, my advice is you look back kind of at the colors. What is under the radical? And that is what goes under your fractional exponent. And then the denominator is the index, and then the outer power is the numerator. And yes, that outer power can slide underneath if there's only one factor. But if there's more than one factor, then that outer power can't just slide underneath quite so easily. All right, let's look at a couple going in reverse. So this time we're going to start with the rational exponent, and then we're going to go to radical form. So here we have 5z to the 1/3 power. So the first thing you want to ask yourself here in reverse is what's being raised to that fractional exponent, because that is going to be what is underneath of your radical. And here, the exponent of the 1/3, that is only applying to the z. There's not parentheses. So this 5 is going to stay out in front of whatever I decide here is going to be my radical and my index. Will clarify. But only the z goes under the radical. So now, in reverse, whatever is under the fractional exponent, that's now what goes back under the radical. And here, the denominator, again, the 3 here, that is going to be my index of my power. So this is going to be 5 times the cube root of z. The 1 is that implied kind of 1 on the outside that we don't need, like that's where the 1 would be, but we don't really want to write that because it's, just to the first power here. So this would be it. So this is 5 times the cube root of z here. And I'll just kind of write here for clarity, like, well, what about that 1? What about that numerator? That numerator, that would be out here, but there'd be no reason to really write that to the first. Okay, let's look at one more. Number 2, suppose we have the quantity of 4x to the 2/5 power. All right, so a rational exponent means some kind of a radical, so we could maybe even just start that right away. And this time, what is being raised to that rational exponent? Well, this time, because there's parentheses, it is the entire 4x that is being raised to that rational exponent. So it's going to be the entire 4x that's going to be under my radical. All right, let's start with our index, which comes from the denominator. And so the index of my radical, this is going to be a 5th root of 4x. And then this time I do have a numerator power that is more than just an implied 1. So I am going to have a power outside of that radical, and in this case it's going to be to the 2nd power. Now, when you put that radical on the outside, that implies it is the whole radical, the whole 5th root being raised to the 2nd power. If you wanted to slide that radical inside, we'd have to be careful here. So again, as we look at kind of what all of our components are, I'd have my 5th root there, and then I have my 4x here. But now if I bring that 2 inside the radical, think about what the issue might be here. Let's say I only wrote it as a 2 here. I just brought that 2 inside the radical in that way. What would be the issue of that? Well, guess what? That implies that only the x is being raised to the 2nd power. And that wouldn't be the same thing because there is more than one, again, if there's just one variable or one number, yeah, you can just bring it on the inside without any trouble. If you bring it on the inside, in this case, you do need parentheses around that for x. So yes, they're both, of course, correct. I probably would go with the first one. I think it's just a little safer. All right, so when we come back next time, we're going to, that's just kind of getting used to going back and forth between the forms and avoiding some pitfalls. When we come back next time, we're going to look at some problems kind of evaluating some rational exponents as we think back to radical form, and we'll do some simplifying with rational exponents also.